this video I am going to discuss the definition of the continuity. So basically, first of all, we will see the geometrically meaning of the continuous. So let us suppose that we have in a Cartesian coordinate system and I want to draw a curve without removing the pen. So it's like continue drawing, but if this curve becomes a function, then we can say the function is continuous function. So now the discussing the mathematically definition of the continuous at a point C. So first of all, function should be defined at that point C. We have a function and which is defined on a domain D. So C should be in the domain D and f of C should be defined. Okay, means the value of the f of C should be exist. After second point is that limit x tends to C, f of x exists. Okay, third point is that limit x tends to C, f of x equal to the functional value at a point x equal to C. So these three conditions will be satisfied, then we can say that fx is continuous at a point x equal to C. So this is in our Cartesian system. So this y equal to fx is in any function and we want to check that fx is continuous at a point x equal to C. So when x is approaching to C from left side and right side, so then our f of C is approaching, f of x is approaches to f of C. So this value should be exist f of C and limit x tends to C equal to f of C. If both are equal, then we can say fx is continuous at a point x equal to C. So if we have given domain D and fx is continuous on all the elements of the D, then we can say that fx is continuous on the D. So we have a lot of examples to check that function is continuous or not. Let us suppose that I will take sin x. Sin x is continuous on the whole real number. Cos x, which is also continuous on whole real number. Polynomial function, all polynomial functions are continuous on R on a set of real numbers. Trigonometry functions, tan x is continuous on sin x. We can write tan x divided by sin x is equal to cos x, but cos x provided does not equal to 0. So these are continuous functions on the real numbers, sin x, cos x, polynomials. And okay, so next theorem is a very good important theorem. So if f and g are continuous at a point A and C is any constant, then following function are also continuous at a point A. Condition is that first of all we have given that f and g both are continuous at point A. Now we are seeing that f plus g also continuous at a point, f and g continuous at a point A. Okay, f minus g, if we will subtract these two functions at a point is also continuous at a point A. Product is also continuous. If we will multiply by any constant c, then cf is also continuous at point A. F of g is also continuous at a point A provided g of A does not equal to 0. So these are the examples. We can construct any function with the help of these 5 examples. Let us suppose that I want to construct x plus sin x. So we know that x is a polynomial function which is continuous. Sin x, which is also continuous on the whole real number, x is also continuous on the whole real number. So x plus sin x is also continuous on the whole real number. So, okay, so we can say directly x plus sin x is a continuous function. Okay, so we can construct lot of examples with the help of this theorem. So next good examples, I want to check that this function is continuous at a point x equal to 1 or not. So first of all, our condition was that function should be defined at a point x equal to c. So here our value of the c is 1. So f of 1, the value of 1 in the above function is 1. Okay. Now second point is that limit x tends to 1, f of x exists. So here limit from left hand side and right hand side, this function will work. For exactly x equal to 1, this function will take value 1. So limit x tends to 1, x square minus 1 upon x1. So that will come limit x tends to 1, x minus 1 upon x minus 1, that equal to 1. So third condition is that limit x tends to c, f of x equal to f of 1 equal to 1. So both are equal, means limit of x tends to c fx, which is equal to the function value at a point x equal to 1. So we can say that fx is continuous at a point x equal to 1. Okay. So we can construct lot of examples with the help of these theorems. So I think we should stop here, and in the next video I will discuss the definition of the derivative and what is the mean of the derivative. Okay, thanks.